Percent of change is another good thing to be able to find. You are going to want to know how to find the percent of change. It has a definition here. Come on, delete. It shows how much a quantity increases or decreases compared to the original amount. The most important part of this is with respect to the original amount. Always comparing to what you started with. So, easiest definitions ever here. Percent of decrease is the change when the new amount is less than the original, and percent of increase is the percent of change when the new amount is greater than the original. Easy. So there's a formula for that. It's the ratio of the amount of increase or decrease to the original amount. So let's look at an example. A school had 720 students enrolled last year. This year, 745 students are enrolled. By about what percent did the number of students change from last year to this year? Okay, just a heads up, you're going to want to round to the tenths of a percent if necessary, because maybe this will come out evenly, but this is safe if it says about. So, I have to find the amount of increase or decrease. I'm going to take the bigger number minus the smaller number, and I'm going to make it a fraction over the original amount. So 745 minus 720, they increased by 25 students, and 25 students out of 720. I'm going to use a calculator. I'm going to make it nice. 25 out of 720 is 0.3472222222222. So as a decimal, 347, okay. But as a percent, move the decimal point twice, you get about, sorry, I'm going to be rounding, so I'm going to use the approximately equal to 3.5%. I rounded to the tenth of a percent. I moved the decimal point, and then I looked at this tenth place of the percent, and one more. Since 7 is bigger than 5, I round that up. So about a 3.5% increase. Okay, we're going to look at a percent decrease. This one doesn't have a word problem. It says it's a decrease. Something went from 576 to 216. So no matter what, you put the original amount is always the denominator, 576. And then we find the difference, always the biggest minus the smallest. So, you got 360 over 576. And then, here comes the calculator. Oops, it's always in the wrong spot, isn't it? 360, oops, divided by 576. 62.5%, because that's 0.625, which is 62.5%. So, we can use this percent of increase here. It says that a professional baseball team announces that the average ticket price will be 8% more than last year. If the average ticket price was $12 last year, how much will the average ticket cost this year? We're going to set a proportion. We know it's going to be 8%, which is 0.08. Just to make things easier, I'm doing that. And then we know that last year it was $12. It's an increase, so whatever the new price is minus 12 will be the difference. So now I have to solve this equation. There's a reason we did this after the solving equations unit. I want to get rid of the 12 on the bottom, so I'm multiplying by 12 on both sides. And I get x minus 12 equals, let's see, 8% of 12. 0.08 times 12. 96 hundredths. and then I'm going to add 12, and the new price is $12.96 on average. We can use this information to find a new amount. It says in 1990, the average price per pound of light chunk tuna was $2.11. The average price had decreased by 7.1%. So 7.1% is 0.071. The price was $2.11. That was higher than the new price. The difference divided by $2.11 would give you this decimal, 0.071. So I'm going to figure out this answer. I'm going to multiply both sides by $2.11, which $2.11 times that 7.1% is, oh, that's weird, $14.91.81, or $1.14981 is that $2.11 minus X. If I subtract $2.11, helps that I still have that calculator open. I'm going to subtract $2.11, and I get negative $1.96. Now, when I get rid of that, what was the rest of that decimal? Sorry. 1.9. Got it. Once I got rid of that $2.11 there, I have negative X. If negative X is a negative number, then positive X is positive 1.96019. But we're going to round to the nearest cent. It's $1.96. So try and find the percent of increase. Always put the original on the bottom. Six divided by 25 will give you 0.24, which is 24%. Always put the original on the bottom as the denominator. And then I'm going to subtract. This was an increase. Here I'm going to go back to number 2. I'm going to subtract 150. Oops. 195 minus 150 is 45. 45 divided by 150. Let's see, 45 divided by 150 gives you 0.3, which is 30%. And this was an increase as well. Well, I guess it was in the directions, but try 3 and 4, increasing 54 by 25%. Okay, it started with 54, and it's getting bigger. So x minus 54 would be my difference, and I'm trying to get 25%, which is 0.25. So I'm going to multiply by 54. Let's see, 54 times 0.25 is 13.5. Then I'll add 54. And that's 67.5, whatever it is. If I'm going to decrease 78 by 40%, 40% is 0.4. I'm going to say, well, the new amount will be subtracted from 78. And it's going to start at 78. And we're going to get 0.4. So I can multiply both sides by 78. I get 70, oops, I don't know what I just did. 78 minus x equals, let's see, 78 times 0.4 is 31.2. Then I'm going to subtract 78 to get the opposite of x. Where'd it go? Negative 46.8. So I could multiply or divide both sides by -1 to get my final answer of x equals 46.8.